Okay, thank you so much, Marcos. Thanks for the invite. Thank you for the opportunity to share. Hopefully everybody can hear and see okay.
Yes, we can.
Perfect. I'm also very passionate about the topic of simulation and operations, so feel free to stop me and be the gatekeeper if I'm too long on certain aspects. Okay. Hopefully everybody can see the slides.
Yes, we can.
Okay, perfect. Then again, thank you for the invite and the opportunity to share. What I propose for the next 20-30 minutes is the following table of content, is to give an overview of who we are, what we do, what our products look like, also to give some insights in our journey as it relates to FlexSim and simulation. Then, of course, a case study where I believe the business problem we try to solve is a very common business problem. What's interesting and should add value is how we solve it using FlexSim. And then some time for Q&A. To start, BOBST, Swiss-based company. Who we are about 5,000 people worldwide. We are leading the packaging industry. Innovation is very important to us. And when we say packaging, there are different types of packaging. We have a very broad palette of solutions for the packaging industry. It can be corrugated board, it can be flexible materials, foils, films, it can be folding carton, and it can be labels. To give maybe a visual of what that means, you can see it on this picture. You recognize some boxes that are quite popular with e-commerce nowadays. You also have labels as you may find them on bottles. Some smaller packaging as you have it here as an example for toothpaste or for pharmaceutical products. Also some flexible packaging, as you can see here, that can hold some liquids. So there's a whole variety of packaging. It's a big business. Each of us, in a way or another, as a consumer, touches packaging and is exposed to it. The industry of packaging is moving very fast. If you think of Internet 4.0, Internet of Things, connectivity, digitalization, automation, it's really important topics. It's the future, but the future already started. We are living it with our products, with our machines. You can also see it in the supply chain from a consumer like you and me when we shop either in a convenience store online, and connecting all the players all the way to what we call the brand owner, who is the owner of the design of the boxes, the shape of the boxes, and eventually the content of the boxes. We are a global company. We have 14 production facilities worldwide, a strong European footprint with our production facilities. But we're also in Asia, we're truly worldwide. It's about 5,600 people. And to get a better understanding of the shape of the products and the diversity of our products, for better understanding the nature of the simulation, what we want to simulate, I added some pictures. The machines are very different. The processes of the machines can be quite different. You have, for example, here a machine that is used for digital printing, for printing of labels. In terms of size, imagine that it could pretty much fit on a truck or on a sea container. On the other hand, you have massive machines and equipment. In that example, it's a picture of a master high-end machine for the coating process. Of course, that does not fit on one truck or one container. It's multiple, and that is really giving you a feeling of the diversity of the products we have. And then imagine on the shop floor when we assemble these products, it's not a one size fits all. It depends on the mix of the products a plant is doing, and the equipment we need on the shop floor in the plant to produce these different machines. There's another slide to give you also visibility to some other machines we have. This one, for example, just to get you a feeling, the largest we do can weigh up to 60 tons, 60 tons. So it's really massive. And the product mix within a factory and the product volume, these are our challenges to manage. And this is where we want to be as efficient as possible and also as flexible as possible. To our journey into simulation, we started in 2017. We had a challenge. There was a plant we had to restructure. It was not an incremental change. It was really a disruption for the plant. We had to completely rethink how we assemble the product mix and volume on that shop floor. And we started thinking about opportunities in the space of simulation. We have heard of FlexSim, and we started very carefully or with small steps to get exposed to it, to understand the opportunities that simulation can offer by collaborating with a university. It was abroad, it was not in Switzerland. Having a very passionate young student challenge us, show us some possibilities. And we use simulation in a very small way on that project, but we got convinced of the potential. So in 2018, in the context of another project, which was this time in India, with a factory in India, we decided to go a little bit further and to train a couple of people to better understand the possibilities, also the difficulties, potentially to be able to simulate, to model something. And we started collaboration with an external party, CCS. In 2018-19, we had then a business challenge, which was a theoretical ramp up of production in one of our sites. And it was, again, not incremental, it was quite disruptive. And the risk in it was quite significant. So we wanted to better understand it and to use simulations. So we did some first models internally. We increased the level of sophistication of our models. And it was extremely useful because we could identify some bottlenecks that we could not see with more traditional assessment methods or Excel type simulations. And we could also start seeing the potential of having quantitative data for building business cases. In 2020, we had another project, this time within the context of warehouse simulation. The business came to us. We are a global horizontal organization providing services to the different businesses, sites, and product lines. And they came to us and said, we want to test changes in the business rules. However, we're a little bit nervous about the implementation, because if we oversaw something or if we missed something, the consequence could be quite bad. So could simulation help us to do something in the virtual world so that we get a better confidence level before we implement it in the physical world? And in a collaboration again with our partner, we could model the warehouse, we could model the changes in the business rules, and confirm the assumptions, but also point out things that the team has not seen. This year, 2021, we had a situation of simulation of an assembly concepts on the shop floor. And this is actually the case I wanted to share with you, where we were challenged about getting extra surface, basically an investment, CapEx, in an additional building. And we said, wait, before we do that, maybe we can test different scenarios, different setups of the assembly of the production on the shop floor to maybe not invest too much in CapEx or too much in an extension. There might be some levers to do it better with the resources we have. And that's how this project started. Going then in this case study or in this model we did, there are a couple of slides to explain what the objectives were and what the setup is. So we wanted to test different scenarios in the virtual world, not in the physical world, and then have some bad surprises. Of course, we wanted to see the as is, use it as a reference, as a benchmark for then possible improvements, and then test different concepts. The drivers or the metrics we used to see if these different scenarios or concepts were good, efficient, valuable, and worth pursuing was the flexibility. And flexibility in terms of resource utilization, square meters shop floor, but also people utilization, operators doing the assembly. It was also related to the capacity of the plant. By changing the scenario, changing the concept, would we negatively impact the capacity in the plant in terms of limiting volume or limiting mix, which of course we did not want. What we did not want was to negatively impact the delivery performance. So what we call the OTIF, on time in full, the lead time of the project or the machine we deliver to the customer. And last but not least, also play with the possibility we have with pooling resources and reassigning resources to different workstations in the plant, and have maybe different skill levels to be able to be more flexible. From a lean or operational point of view, to make it very simple, we can imagine three key setups or three key scenarios. One of them, which was the original one, is that the whole shop floor was segmented in areas. Each area for a specific product type, here just represented with product A, and that shop floor area would only produce this type of machines with a certain size, a certain complexity. Then there's another area in the shop floor, product B, where we reserved some surface only to make that product slightly different geometry, different size, and slightly different complexity, content of assembly hours, complexity of test, and duration a product is on the shop floor to be assembled, and so forth with product C. So very, very segmented, I would say quite traditional. The first scenario we tested, and that's really what the case is about at this stage, is to say, can't we just divide the shop floor in lanes or in bays, all of them equivalent, so quite generic, and each bay could be used for the assembly of product A or B or C, depending on how they come in the production plan. So the flexibility is better, is improved. However, we wanted to see the difference or the comparison with the first scenario in terms of surface utilization, resource utilization, capacity, and lead time. And then eventually, and this would be the next steps of our journey, of our project in that plant, is to say maybe there's an even more disruptive concept, which is to go with tacted lines, so that not only the lines can produce each of the different machine types, but also to have a better visual management, to have a better control of the progress of the assembly. So what the simulation that I will share is about is mostly this middle section, and it's quantifying and understanding the benefits of not having a segmented shop floor, but a more generic shop floor. This is what it looks like, a couple of concept slides to give a feeling of what the parameters or the key parameters are, and then we'll go in a live demo. The shop floor is the whole surface you see. There are bays. Each bay has the same width, so that each bay can accept any of the products. Again, it's a high variable product mix with a low volume, low yearly volume. So we are in the single double digits, maybe the hundreds, but we're definitely not in the thousands, 100,000, etc. This is what our industry is about. The colors show the advancement of the assembly, the different stages. So to make it simple, you have the workflow here. We start with mechanical assembly, and in parallel or sequential electric assembly, followed by software installation, and then testing and FAT or factory acceptance test. So depending on the machine, these durations are not exactly the same. More complex machines may have more testing. There might be customization. So each machine or machine type has a different variability in the process, but the process sequence is pretty much the same. The way we fill the shop floor is starting in one corner. Imagine a warm-up where the shop floor is empty. Maybe after a holiday, we would start in the upper left corner and then put the first customer order, the first machine here, then the second, third. When the lane is full, we go with the second, the third, etc. And so we fill the factory that way. Once a machine is completed and finishes with the factory acceptance test, let's say this one is finished, it empties the spot, and then this spot would be available for the next customer order machine. So that's our production planning. We would insert it here, unless the spot is too small, in which case we would then look for the next space in an empty bay. This again is the sequence of the assembly of a machine. We start with mechanical and electrical, software installation, test, factory acceptance, and each of these process steps has a pool of skilled operators. This is what we represent here with the different colors and the pools of operators. Of course, the size of the pool can be different. We also integrated the concept of shifts to test the benefit of having a second shift or not, maybe only for certain pools of resources, and to get something quantitative to discuss with the operations director of that plant. In principle, we work in one shift. We also wanted to see what is the benefit or the constraints of having a second shift and the impact on the resource pools. And then what is very powerful is not only you have a visual tool to communicate with the shop floor personnel, the visual to recognize a machine, a specific machine, was not important. So having a square or a block as a conceptual machine was sufficient. Even so, we know the software's capabilities to be even better in terms of rendering, but for that project, that was good enough. and then to say, well, look, this is what would happen if we change the concept. And these are then the quantitative outputs of the simulation of the what if in the virtual world, to play with the different parameters, to do a sensitivity analysis before we make the step and say, yes, okay, now it's a go. We are comfortable with what we want to change. We know where the risks are. We know where the surprises are. We know how to tackle it. And now in the real world, in the physical world, we can make that change. And the risk is managed, and it can be much better planned. On that screen, what you would see is for each of the operators. So the data here is fake, of course. Some of the data is confidential. We cannot share everything, but for the functioning of the model, it's good enough. We have a number of operators in the pool. In that case, 23 operators are simulated for mechanical assembly. And then we see their utilization. So in that case, it's not a good utilization, it's obvious, but we did not want to put the actual number of operators and the actual data due to some confidentiality reasons. What we can also simulate, and what's very interesting, is the lead time as we plan it in our production plan, and then see if, as we go with that model, adding a bay or removing a bay would have a negative impact on the lead time of the machine over the year. This is a video. What I propose is to switch to FlexSim directly. So what is also very interesting in the way we can simulate and extremely powerful to us is that we can set up some data, some parameters in a table. For example, the shift model when they start. We can also set up all the geometry of the plant that makes it very flexible if you want to use it for another plant in terms of dimensions, number of bays, width of the bays. For each machine type that we produce in that plant, we can also define the geometry of the machine. So let's say the footprint of the machine, the assembly times in the different process steps, the production plan, the sequence of the machine. So you see that it can be quite variable. It's not that we have a batch of 10 machine type A, and then in the year, a batch of 20 machines type B. It's really a mix of machine types with expected start and end date. Also the resources, we can play with the number of resources in the different pools for the different activities, mechanical assembly, electrical, testing, etc., for each month in shift 1 and 2. So it makes it extremely powerful and flexible. And then running it. And hopefully it will work. There will not be the demo effect. Okay. So the plant is warming up and filling up. You see the color code that makes it very visual and easy to explain to shop floor operators what's happening, the consumption of the resources based on the data we put in the tables, and then most importantly, the surface utilization with the current utilization, average, maximum utilization, same for the resources in the different resource pools. Here, this is the software resource pool. Also the expected start and finish date compared to the simulated one. And then the location table where we put the different equipment in case there would be a specific crane type or jigs in some lanes only, so that we can play with that. Going back to the slides. Can you see the slides again? Hopefully it works.
Yes, we can.
Oops. Okay. In terms of lessons learned, the benefits is that we talk a lot about digital twins here. It really is with the level of granularity that we choose to use. It's playing, simulating, testing business rules, fixing issues before they happen, and moving to the physical world with a disruptive change once the confidence level is high and once we have eliminated the risks. The as-is validation of the first iteration may take some time. Often it takes a little bit more time than what we'd like to, but it's time well invested, because if the validation of the as-is good, then the to-be, the changing of the parameters and simulating the different scenarios is quite efficient and quite fast. It's a very powerful communication tool. Even so, we have squares only and not the perfect visual of the machine type. In that case, it's absolutely sufficient. And as you show it, as you demo it to people who do it the whole day, who are absolute experts in assembling the machines, they come up with ideas. They make adjustments to what you show them. And that's really the value of it that you cannot do in an Excel, let's say, or in a PowerPoint. Last but not least, it's quantitative. So for building a business case or selling it to management, you have some solid numbers, and you can justify it, and you can go all the way to the root of the numbers. Some areas of caution. It's not always obvious for people on the shop floor to use simulation, to use tools like FlexSim. There might be a very initial perception that it's too sophisticated, that it's maybe a PhD type environment, but very quickly when they see it, they warm up, they open up, and the discussion is really good. The level of granularity of the simulation might be a challenge. Going too deep could cause a lot of complexity, and often for the business decision we make, we don't need that much of details. So agreeing on the right level of granularity for the decision we want to take is important at the beginning of the project. There's always a tendency, once you validate a concept, that people challenge and then say, okay, for that very specific customer order and that specific machine, show me. Well, no, that was not the purpose. It was more a concept validation. It's tactical, it's strategic, it's about CapEx, it's about average values, about trends, deviations, but it's not in our case for a specific operational case of Joe starts at 8 o'clock in the morning and he's done at 10 o'clock or 10:15. This was not the purpose of the simulation. And last but not least, a good simulation requires a very good and balanced combination of knowledge of the tool, of some programming maybe, but also the business knowledge. It's not one or the other, it's really one as well as the other, and it has to be balanced. And with that last slide, for that balance and for the insights of the tools, the leverage we have with our supplier and partners, CCS, Commercial Consultancy Services in India. If Mano is online as well, a big thank you, and the support and help always very much appreciated. With that, I'm at the end of the presentation. Hope it added value, generated maybe some questions. And if it's not confidential, I'm more than happy to answer the questions.